Okay, so as I mentioned, cross-site scripting, or XSS, there's three things we need to understand with this specific topic, and that is there's three different kind of methods of attack. One is non-persistent, and that can be specially crafted URLs sent in an email, an instant message, blog post, etc., etc. So someone will send you a link or send you some type of communication. You click on that link, and then it's going to interact with a third-party website, and that's going to be the primary method of attack. Next would be DOM-based or document object model-based, and that can be persistent or non-persistent as well, and that's used to hijack sessions. So as you interact with a website, this specific attack can be used to hijack that session. And then we have persistent, and that is server-based, and that can execute on a user's computer just by visiting an infected website. So this is really, out of the three, the most dangerous, because if you visit a website that has this type of persistent cross-site scripting attack entered, okay, it could be hidden or could just be some type of piece of code on a page, the attacker doesn't have to actively be trying to pursue you or actively trying to infect your computer. They can simply infect a website, leave it sit there, and kind of sit back and wait, and then people who actually come to the website then become infected. So it's much more kind of just a dangerous attack overall than these other two, which are actually, it takes some manual intervention and some actual steps to be followed. So cross-site scripting prevention, we need to make sure that we validate and sanitize. So input validation, okay, that's the primary defense against cross-site scripting. That's the takeaway that I want you to understand out of this specific slide, is that we need to validate and sanitize. So if we have inputs on our applications, whether it's a website or what have you, we need to make sure that we validate and sanitize so that someone can't put in maybe a long line of SQL code or an HTTP GET or POST, right? So they can't put in something that we don't necessarily expect. If we're asking someone to enter their name, we don't want them to be able to enter 200 or 300 characters worth of SQL code or what have you to basically try to break the system, break the application, enter in some type of malicious code. So validating and sanitizing will prevent that. And then we need to test and more testing. Internal testing, we can use the fuzzing tools that we talked about previously. Okay, and as an application developer, they're going to have their tool sets that they use, and that really is crucial to discover vulnerabilities in the application. And then we have two choices here when we're doing this type of validation. It can be client side and server side. Client side, although maybe a little faster, is bypassable. So we can turn off Java. We can write specific code to kind of bypass that and take just the amount that will be posted to a web page and clean it, kind of scrub off the stuff that the controls are in place. A malicious hacker can bypass that client side validation. So server side is going to be more secure. They don't have access to the server code, hopefully, and so they cannot go in and change that or bypass that. So we can do both, but one or the other rather, but we should really do both to maximize our defenses against this type of attack. And then the next thing would be cross-site request forgery, or XSRF. Sometimes you'll see it written as CSRF, and it's pronounced CSRF. All right, so that's going to be exploiting a website's trust in a user, whether it's an application, an IP address, or what have you. All right, so it's often referred to as one-click attack or session riding, okay, CSRF, as I mentioned. And I'll talk about a little bit more graphically here in just a moment. But it requires the victim to have recently visited the target website. All right, so basically, let's say someone's trying to attack a bank. That would require you to have recently visited that bank and have a cookie that's not expired from that bank. And then their attack can then leverage that cookie, go back to the bank pretty much as you, because the bank trusts the authentication of your computer. This attack pulls off a valid cookie from your computer and then attaches or connects to the bank and basically impersonates you. It's not as widely exploitable because obviously it's very specific and someone has to kind of almost luck out and have things kind of line up for you to have visited a specific website. They have to actually be targeting that website, and you have to have a cookie that's not expired. So it's not as exploitable as you might guess. But here's an example of how it might work. All right, so an attacker, again, visiting pooru.com. The victim is going to click on a link. So they're going to basically send you something or post something or somehow or other get you to click on a link. So you click on that link, the browser is going to go to the attacker server, get that response, and there's an invisible submit form. Basically, that attacker server is going back, pulling off of your computer the cookie and the session information that it's trying to get. And then it's going to post that information back to the bank's server as a valid session ID. So in other words, the attacker is going to basically hijack your system. They're going to send some type of malicious link. You're going to click on that link thinking it's whatever. Get a free this, get a free iPad, win a vacation, click on this funny cat video, whatever the case might be. Somehow or other they get you to click on that. That takes takes you rather to their website. It has an invisible form on there that goes back to your computer and pulls off a cookie or some type of session information to where they're actually trying to get to. Okay, the real target, which is the bank. It's going to send it from you. Okay, it's going to have that information basically from you, rather, your IP address, your authentication, your cookie. And then once that gets there, they're going to be able to then initiate a session with your authority, with your credentials, and then get into the bank or whatever the target website is as you. Okay, so it's very specific, as I said, but it can be very dangerous because if they're successful, they can basically impersonate you and do anything that you could do on that specific website. So, some distinctions between cross-site scripting and XSRF, or cross-site forgery requests. So in an XSS attack, the browser runs malicious code because it was served from a site it trusts. All right, so basically the browser runs code because it was served from a site that it thinks that is trustworthy. In a XSRF attack, the server performs an action because it was sent a request from a client it trusts. All right, so you see the distinction. In cross-site scripting, your browser is going to run malicious code because it was served from a site that it trusts. Basically, you're visiting a website that has malicious code on it. In a XSRF attack, the server, in other words, in this case, a bank, is going to perform an action because it was sent a request from a client that it thinks it trusts. So the attacker has compromised your credentials, your authority, or your authentication, I should say, and now they're attaching to the bank as you. So there's just a clear distinction that I want you to have as a takeaway between cross-site scripting and the cross-site forgery requests.